Hi guys, welcome to another chemical engineering tutorial brought to you by the ChemEng student. In this lesson we're going to take a look at the difference between diffusion and osmosis. This is the second video in our May competition whereby you can win £1,000 every month for an entire year. So be sure to watch till the end to see the question on how to enter. So before we look at the key distinctions and differences between diffusion and osmosis, it's good to make a note of the key terms in the nomenclature that we are going to be referring to throughout the process. So when we talk about these two terms, there's three things that we need to be familiar with that correspond to both diffusion and osmosis. And those are known as the solute, the solvent, and the solution. The solute is the substance that is dissolved. The solvent is the bulk fluid, and the resulting mixture is known as the solution. And a good way to represent it would be something like this. So you can clearly see here we have the individual orange particles are the solute. So these are the substances that will be dissolved. The bulk fluid is the solvent, and the resulting mixture of the two of them is known as the solution. And an example of that would be, say, coffee. So your solute, if you took sugar in your coffee, then the sugar would be the solute because we would dissolve that. The solvent would be the coffee, and the resultant solution would be a sweetened coffee beverage. So that's a real life example of the idea of diffusion. Now we'll take a look at diffusion first before looking at osmosis. Now, diffusion can be defined as the movement of material in order to establish either an energy or a concentration equilibrium. And this can occur in any medium, so it can be within a solid, a liquid, or a gas. Any of these three states, you will be able to establish a concentration or an energy equilibrium through the process of diffusion. Now, with diffusion, there's no need for what's known as a semipermeable membrane. And we'll look at more of this in detail in just a bit. Because for osmosis, there is a condition needed for a semipermeable membrane. But in terms of diffusion, diffusion does not require a semipermeable membrane to function. And its driving force is a concentration gradient, i.e. you go from high concentrations to low concentrations. And it can be deemed a passive process because diffusion of any sort between any material can take place without any intervention whatsoever. So for example, if we go with the coffee, if you were to pour sugar into the coffee and just leave it, over a prolonged period of time, the equilibrium for the concentration of the sugar would establish, but the sugar would diffuse into the coffee by itself. Granted, if you mix the sugar, you just increase the diffusion rate, so you decrease the time in order for a concentration equilibrium to be established. Now, a good pictorial representation of diffusion is as follows. So if you can imagine the red particles as, say, sugar, then in this corner we have a high concentration of sugar. But the rest of the schematic is low to zero concentration of sugar. But over time, you would see that the particles begin to spread out, filling the overall geometry. So if you can imagine this as the cup, then it slowly fills the cup until the concentration has reached an equilibrium, i.e. the concentration at any point in the system of the red particles is the same. And that's how diffusion basically works in a graphical representation. Now, if you consider osmosis, then osmosis is defined as the movement of liquid, and it's usually water, that passes through a semipermeable membrane. So osmosis is just a sub-part of diffusion. but it's one that requires a very specific piece of, I wouldn't say equipment, but there is a condition needed for this to work. And the concentration of the solute does not have to become equal across the membrane. So, for example, if we take one of the more common examples of osmosis would be in dialysis. So, if your dialysis machine for purification of your blood in your kidneys, then the concentrations of, say, the salts in your blood to the urine stream, they won't be the same on either side, and they will never become the same on either side, because that is not the function and the process of osmosis, whereas it is in terms of diffusion. Diffusion wants to have an even concentration within the entire mixture. Osmosis does not. Now the rate this time is very dependent on, first, the number of solute particles within the system and the membrane resistance, because how the membrane behaves will dictate how easily or how difficult it will be for the solute to actually pass through the semi-permeable membrane. And it's also very susceptible to pressure changes, because a lot of the time in osmosis we talk about biological systems, but more importantly, when we talk about pressure, that can influence the size, the shape, and the availability of this semi-permeable membrane. It could either close it permanently, or it could rupture the thing in its entirety, and you then go to a diffusion process. Now, it's most typically associated with water and salt systems moving in and out of cells. So the question now is, what is a semi-permeable membrane? And in simple terms, it's basically a membrane, if you think about it, say in terms of your skin or one of your organs, which allows only a selected type or size of molecule to pass through. And a very good pictorial representation here is of a cell. So what we have here is we've got our membrane, so this would be our semi-permeable membrane. This is the outside of the cell, and this is the inside of the cell. So what this does is the membrane, in this case, and again there's a lot of different mechanisms and biosynthetic pathways for how these actually work. But in its raw form, if you can imagine that we have potassium ions, we have sodium ions, and we have chlorine ions. Now, these all have different sizes. So if you can imagine that out of them, sodium is probably one of the smaller ones. So say your semi-permeable membrane is only big enough to allow sodium ions to pass through. Anything else, it will not pass. It won't fit. So that's an example of a semi-permeable membrane. It only allows a certain size of molecule through. Another type of semi-permeable membrane would be one that requires the use of chemical identifiers. So things like enzymes. So an enzyme can have a special code that when it is read on the membrane will allow the door to open and allow that material to pass through. So that's really the two key mechanisms for semi-permeable membrane, but the actual biology and the chemistry behind it is out with the scope of this tutorial. Now, one thing to note when we talk about osmosis is the idea of osmotic pressure effects, and this tends to be associated more with blood. So the movement of water or salts into your bloodstream, because we know that it's heavily dependent or influenced on the hydrostatic and turgor pressure. And what that means is we can have three potential options here for the osmotic pressure effects. And the three options are, we can have hypertonic, we can have isotonic, and we can have hypotonic. So hypertonic simply means that the water concentration outside of the cell is lower. So the water will leave the red blood cell. Therefore, the red blood cell will become dried up and shriveled. So basically become, it's not going to work. So that's in a hypertonic. That's when the concentration is lower outside than it is inside. Isotonic is when we have equilibrium established through the rate of osmosis coming in to the rate of osmosis leaving. So that is the established isotonic pressure that you would have currently in your bloodstream. A hypotonic is when water, surplus water, enters the cell, i.e. you have a higher concentration outside the cell than you do inside the cell. So water enters the cell and it ends up bursting the cell. It pops because there's too much water inside the cell. So that's the three types of osmotic pressure effects that is associated with the movement of water in the bloodstream. And again, that is, you can move that and transcribe those effects to other applications as well. So now is your chance to win £1,000 every month for an entire year. And all you have to do is answer the following question correctly. What is the distinction between a hydrostatic and a turgor pressure? So in order to enter, all you have to do is comment your answer to this question, like and subscribe to the channel, and make sure that you subscribe to the Facebook page, as that's where we will announce the winner at the 5th of next month. Entries end on the 31st of this month, so be sure that you comment your answer before the deadline. So that's the end of this lesson. Thanks for watching. Hopefully this was helpful in understanding the distinction between diffusion and osmosis. If you liked this video, please consider liking and subscribing to the channel. It really helps us reach as many chemical engineering students as possible. Thank you for your time, and we hope to see you in another video.